Network in this one transition of the slides.
It's now you have to
Here.
turn it on. Yeah.
Start.
Yeah.
Finally, I'm start getting nervous.
And that's with.
No,
Let's
not
see.
changing.
It's not changing.
Yeah, so which one is here? This. Okay, now it's changing. I removed the. I think it's all fine. It's all fine. Now
It's all fine. Yeah. Okay. Okay, so I use 2 minutes and go and close the door, and then I come down and introduce.
Я ж не писав. Да-да-да. Главное, что состоялось. Just in time.
Just in time.
Okay, so with this small delay, and now also I think that most people has found the room, I like to welcome to this spectacular event. So my name is Carsten Thur Jacobsen. I'm head of department for environmental science, and we are situated in this beautiful setting. And we're so happy that people are coming to visit us and listen to what Sasha has to tell us today. So I think that the whole area of the, how can we actually perform? What are we doing with our environmental data science? How can we put the data into work? And how can we make it available for politicians? Then mapping is a fantastic way to get around it. And I think that we are very, very happy that we now can beef up our group working in these areas with Sasha. So without further ado, I would give the word to you.
Thank you very much, Carsten. And thank you very much, dear colleagues, friends, for this exciting day, even whether a little bit changed, but this is a perfect momentum to get together with promotion to the full professorship and sharing this exciting moment with you here. I would start first of all with a small, not exercise, but explaining this long name, maybe once to spell. So Alexander Vladimirovich Prishchepov, both in English and how it sounds in Russian as well. But you also know that I go for Sasha. So that's introducing myself and being privileged here with the progress toward to the full professor of land system science. I entitled presentation, Moving Toward to the Fair and Sustainable Land Systems and How Advancing the Remote Sensing and Modeling of Land System Change. Before going and bringing you to the journey and looking together how science progress, and I was this part in the science of remote sensing, I would like first of all to thank my family supporting on this journey, but also my colleagues and the team I've been working for the last decades already, and also numerous collaborators. So we have institutions, but it's primarily people who were behind to that. So I'm deeply thankful for this opportunity, for this journey, and being able to stay here and performing and presenting for you. So I would like a little bit to warm up atmosphere. And nearly 30 years ago, I was actually in Copenhagen. Mm-hmm. And now thinking through that I was here as a young student, brought in a sailboat staying in Amaliaborg, I could barely imagine that after 30 years, I will become a full professor in Denmark. And I would like to challenge you, challenge some of us, if maybe you will recognize me here. So what is your guess? So somewhere here or here? Okay, so I was here, so I was just 18-year-old, a student, first-year student, and I would not imagine that after some time I will become as a captain of the board and being here in Denmark. So for me, it's a great privilege to become a full professor in Denmark. So let me now to bring you to the journey with me, and I will be discussing today about the growing relevance of the land system science. Also, we will see together how science advanced in terms of the remote sensing and modeling land systems and key lessons from the past research, and also how I envision the pathways toward the fair and sustainable land systems. And this is just my journey. Somewhere I got started, and now I'm here for like a paper airplane flying for the life. So one is a most fundamental challenge I would like to address here. So what is actually land? Land, we may think it's some soil, tilt, what we see in the fields these days in Denmark. But in fact, actually, land is not just merely the soil. It has more values, meanings, and implications. And I would like to bring the quote of another renowned scholar. It's like these days I stay in an auditorium dedicated to Niels Bohr. I was defending a PhD with in auditorium of Aldo Leopold, environmental thinker, who stated that the land is the fountain of energy flowing through the circuit of the soils, plants, and animals. So we have energy which is flowing through the different systems. And in fact, land is a system. It has both biodiversity component, it has also biochemical cycles, energy flow. It really values to us in terms of the food we eat and produce, but also supporting the livelihood. So besides of the soil and animals, the humans are the part of this land system. And we need to monitor these processes. So thinking through land system in the human dimension, it's like some people maybe remember about the Pink Floyd. We have different drivers. So both political, demographic, institutional, and it's also close to the heard how politicians in the recent elections were discussing about the state of the land in Denmark. But this all has a shapes to the land systems. And as an outcome, we have also food and fiber, ecosystem services, and this all we need to measure. So measure both the drivers, but the state of the system and the outcomes. That's what it brings us to the very important point. How can we measure these processes? And this is not something what was kind of the common these days. It was always with the population, with the curiosity. And that brings me to this early explorations. We will not go this time to the Greek period, but at least to bring the Alexander von Humboldt in his travel with the Bonpland to Chimborazo, Ecuador, and seeing this beauty of interaction between the vegetation and the climate. But also if we see here also some openings, perhaps it's a part of the natural systems, but also its presence of the human dimension, albeit they were traveling and together, some of them, but also we see some other interactions. That was the time when it was aspiration. So both some recordings, natural exploration, but also a lot of emotions with the aspirational perspective. Another, his colleague Pimpel was Adam Johann von Krusenstern. He looked not in the terrestrial part of the land, but at the oceans and the currents. He did the first circumnavigation, and on the way back to St. Petersburg, he had to explore and to find a way, if it's possible, between the Sakhalin Island and Eurasian continent. He was fast enough, not sufficient resources, so he made the mistake. He stated there is no bypass. And it took years to clarify this mistake. But if he would be equipped with the satellite imagery, if we see with this footprint from satellite from the Google, he will probably found immediately that there is a bypass. So we would need to wait for decades or so. That brings us to the important momentum that we need an urgent need to monitor the land systems, both looking at the scale, so large scale coverage, repeated observations, capabilities, so look both at the updraft and gradual dynamics, and also being objective. So being able quantitatively to interpret these findings and the patterns as well, so to avoid any bias. We live in a exciting time, sometimes not completely excited about the weather and political domains, but looking at this picture, which appears these days in the news, we see not just only the beauty of our nation and also of the Earth surface at some distance, but also we see technology behind. Being able to record at some distance, being able to compare how Apollo mission was passed and what were the changes. This is also what brought my excitement, being a person who works with the remote sensing. But somewhere it had to be started, and this is how sometimes it got started. So we look at the both successes and failures, some curiosities, and being able to record at some distance how the planet looks like. Well, there been some other parts. So before entering my era, so this is a photo of Copenhagen, or in fact several photos, and it already shows it's not just a footprint, but also different technologies behind to bring the geographic coordinates, bring the imageries together. And if we would have also a sequence of these observations, we will be able to detect the change. So this back to 1930s. And this is what it comes, finally, this era of the satellite data, where made me completely excited about, and I decided to spend all my life to work with the satellite data. For me, remote sensing is not just technology. It allows us to record the pulse of the planet, like the heart. Sometimes it beats fast, sometimes it beats slow, and we can record different reflections, different processes which are happening around the world. It can be vegetation. Nowadays, we see how vegetation is blooming, thriving, spring starts, or rather opposite, beautiful autumn. So phenology. We see urban sprawl, how things are developing. We also see some disasters, natural disasters, hurricanes, but also man-made catastrophes and the wars. This all we can record using these techniques. And that brings me here to this momentum where I had a little bit more hair first. So where I started being excited about remote sensing. And I would say my journey, and I'm bringing you with me to this journey, was the early pioneering works in the remote sensing. I was in very privileged conditions, thanks to the NASA grants and the colleagues and my PhD advisor, working with this data with so-called commercialized public data sets. So I was privileged enough to have a data to work, which were purchased, and start analyzing the change with these observations, building the science and building technology. But what inspired me probably the most, also making excitement, is this. So what sometimes I say that the pictures or images, they give more than just thousands of words. And this was related also to my heart because it shows some political transformations which we can record with the satellite data. Collapse of the Soviet Union. We do not probably depict the boundaries between the countries, but what we really see is here that some economies, they thrived, a lot of red, change in the nighttime lights, and bluish indicates opposite process, downturn in the economies. And nighttime lights, which sometimes we see in the night, cities are blooming with their lighting, so it means a lot of things are happening. In other parts, we see the darkness, so not much is happening, so economy may also go in a decline. So that means the technology can help us to analyze not just the pixels by itself, but tell the stories, both economy, but also political. And that meant also to me and to the team I've been working that we could potentially expect some rapid transformations in terms of their land use change. So as I mentioned, I was privileged enough, and my PhD advisor, he spent quite a bit of the portion of the funds to buy imagery and start analyzing. So this was just a snapshot, one snapshot, where we start looking at these rapid transformations, the reds indicating a massive abandonment, while in other parts, there was not much abandonment, like in Belarus. So that meant that political system differently responded to the transformations. This was a momentum where we start analyzing that we can tell also the story, reveal economies and political transformations and how this impacts the land systems. This was also the time of the paradigm shifts. It was still my PhD time, and this is how interesting and also a little bit crazy how things were developing so fast with the remote sensing aspects of the land system science. So if you look here, we see so-called freeing the satellite archives. So once the images were in my PhD time around $600 per just image, and then they became suddenly for free, all archives. And you see how much it helped to boost publication record. So once the technology which was available to few became available to everyone, how much it changed also the science by itself, how many storylines, storytelling we observed, and how science progressed with the remote sensing. So that also allows me from my PhD very quickly move to look at the larger perspective. So seeing what we could not see before and get some whatsoever statistics or other factors, how political transformations in the same agro-environmental conditions, they differently shaped where abandonment was more pronounced, land were withdrawn, and where it was suppressed. But what was also exciting, it was not just about the mapping the patterns. We start moving to the next frontier and linking the people and the pixels, understanding the processes behind to these transformations. And here you probably see some similar agro-environmental conditions, but like a low yields, we would expect more abandonment. That was not the case in Lithuania or in Belarus. Well, we know that there is a different political regime, and this is where there was one of the shocking outcomes, how different political systems they shape the landscapes. There have been a lot of work in the front of the satellite, in the front of the computers. We always equip with the computers, with the monitors, but it was also a lot of touch to the ground. And you see that we are not only sometimes remote sensing people sit in the office, but within a lot of field components and talking to the people who were part of these processes, agents of change. And this is a part across the Central Eastern Europe. And some of my colleagues, we did together PhDs at the time, exploring parts of Lithuania, Russia, Carpathian, Ukraine, seeing where the things were changing so fast. So that also quickly, we move from what I was showing a snapshot in time to the continental scale. We start seeing the large pictures. We start analyzing at the very large scale transformation land use intensities. And what was also important to understand that we start seeing broader, larger signs. As I depict one of the slides from my postdoctoral advisor, Daniel Müller, we observed that some systems that stood as the same, were not impacted, they are quite resilient, and others, they shift to the new land use regimes. So this is where the signs also start appearing beyond to the pixels. So to summarize a little bit, so this period was, and I was largely a part in contributing and developing, where we have advanced in a satellite image analysis, connection to this environmental and societal impacts of the land use change, and observing the major hotspots of the land use change globally. This was this time. As a takeaway, the move from the mapping versus understanding the processes of land use transitions. So that kind of equipped me with the techniques, with the science, and seeing what we can do with the satellite data. And that brought me explicitly to the postdoctoral work on this journey, scientific journey I bring you with me, where we start looking at the continental scale and moving a little bit where we didn't know much about how political transformation would affect the systems working across the Eurasian steppes, Kazakhstan, Central Asia, working both on the ground, but also with the decision makers, stakeholders, and seeing a very large transformation, colossal transformations, which later we quantify to connect with different processes such as the global biogeochemical cycles. So that allowed us not only to benefit on the science of remote sensing and other aspects of geospatial knowledge, but seeing not just the land use change, but seeing the land as a system, both quantifying whatsoever carbon emissions or opposite decrease, and also different causal linkages between the different processes. And that brings me to the scheme I would like to show in the next slide, from correlation, slowly going to the path dependence. So using the new techniques, because also the availability of the new data and progress, how things are interrelated, how they are impacting each other. That was the time when the progress appeared. So as a summary, that was a period of maturation, also the emergence and maturation of machine learning, where we could process and make more accurate analysis of the land use change, also working finally with the open data perspective and toward the land system science moving, and also more exploring and more maturing with the path dependence. So more holistic land system thinking. And that brought me to this exciting pathway with this scientific journey I'm traveling with you today, coming to the University of Copenhagen. We start being more equipped and thinking more critically how we can combine all existing technologies and ascribe and quantify the different features related to the land transitions. In that way, we matured and brought together different observations, also from different platforms, and seeing more nuances about the transitions. This was a time, thanks a lot for the work with the colleagues, for instance, Hein from Associate Professor Kent State University these days, and also the Chantian Ho, that not just the imageries by itself, but all this detailed data, all richness of this data allowed us to develop new approaches, how we can analyze the subtle transformations related to the land systems, which we would not been able to do it before. What was also this time, and just still happening these days, we start appreciating, which we would not be able to detect before, analyze before, it's so-called small geographers. So how small geographers may have a large impact, no matter if it's the small artillery craters quantified with the satellite imagery across the eastern Ukraine, or multifunctional landscapes in Europe, or individual trees, as colleagues Martin Brand, he did at the University of Copenhagen. So millions features have nearly were neglected before, had multiple values in terms of the different processes around the world. Probably it's quite important, it's also a paradigm shift that we're thinking about the terrestrial landscape, vegetation, but remote sensing is also gives us ability to state that land also has a social dimension, and how we can measure this dimension. And I bring an example of Denmark. It's a work with a supervised PhD student. She is assistant professor at University of Washington, Karen Chen. How different neighborhoods they are growing across Denmark, if it's in Copenhagen or in Aarhus, and it has not only values of the buildings, but also the mental health. So we could potentially guide the policymakers how knowledge about different neighborhoods, lack of the appearance of the green space, has an impact on the mental conditions of the people. So remote sensing also allowed us to sort of break the frontier and to look at the social domain, as I was showing with the political science, nighttime lights, or here pushing the frontier and looking at the social. Last but not least, here we start bringing holistically things together, not just the drivers or the patterns by itself, but thinking about the archetypical behavior, archetypical patterns or syndromes of the change, not just the one trajectory, but multiple trajectories. If it's a land use change versus the different types of the socioeconomic transitions, how we can quantify and bring this to the policy making and showing that these areas maybe require a very specific way of design of the policies. So as a summary, that for this very important period, we start observing the deep learning and also multi-source imagery, how we supposed to bring the science, bring things together, but also maturation of the land system science with this holistic thinking and understanding the fine scale geographical change, what it matters for us. So also the capturing signal of social, that was also very important, the breakthrough component. So as a takeaway, this is a time when planetary scale thinking was coming and to also enable us to equip to bring the theories up front. So thinking through land system perspective, meta theories, meta-analysis, and some mid-range theories, this all was coming thanks to the advances in remote sensing science. So as a summary of the small journey, so we started with the discussion one snapshot in time towards seeing the processes, so not just mapping the change, but also explaining why and how this change occurs, and from snapshots to the dynamics in a planetary scale. So time series revealing the trajectories, also the regime shifts, but also path dependencies, and from the data to the system inside. So remote sensing now became central to understand the coupling of the environment and society. I would like to revisit the statement, to actually expand the statement of Aldo Leopold, environmental thinker, who stated in a Sun Council Almanac, a very iconic book about environmental perception. So land is a fountain of energy flowing through the circuit of soils, plants, and animals, but it has also other meaning. When the change occurs in one part of the circuit, may other parts may adjust themselves to that. And remote sensing allowed us to look at these changes, also in the energy flows and outcomes and different implications. That brings me to this important momentum of becoming a full professor in offline system science, remote sensing, and land use modeling, and making this statement. We live in exciting times. Maybe it's a bit provocative. We see that world sometimes falls apart with the politicians. The weather maybe is not anymore nice as it was in the morning, but bringing from the thinking that how much data we have these days, different sensors, amount of the data, deep learning, we have everything what we can do and progress the science forward. And this is what it brings me here as a professor to think about my next steps and making a statement, moving from the observing the land change to more fair and sustainable land systems. And I will explain what I mean under the fair and sustainable land systems. So me, as a professor, I see my mission and vision, where to move the next. First, we need still to progress, and since the land has a multiple meanings, we also need to have a multiple dimension how to measure with the satellite data, so to progress the science. So this is the point number one. So that multi-source remote sensing is still valid, and we need to find and develop science how to bring the things together to ascribe different features. So that means we also need to have a new sensing paradigms, how we combine data, maybe new sensors. We should not forget about also social sensing, how we bring with the satellite imagery. We need to understand we would like to measure processes, but not the state of the land, so the states. So also to understand the subtle transformations. As a point 4, cross-scale interactions. We see that in the nation, we should be able to measure that as well. So that another advance should come and I should work. I will be working on that. Number 5, path dependencies. We are still in a process of understanding interrelationship, and remote sensing science exists a little bit more than for half century. So that means a lot of things to do to understand causal effect relationships. I bring also normativity, the way how we define what is the forest, what is the abundant lands, what the people may have very different visions about what is cultivated or not, what are the multifunctional landscapes. And this also requires us to rethink from the remote sensing perspective how we measure that. Small changes, as we witnessed, have substantive impacts, big impacts, both locally and distantly. And this is what also we need to progress the remote sensing to being able to measure this small transformation. Fair remote sensing. We have all techniques, but very few that have the access to this data. That also means that we need to work on transferable approaches and also working with the even public data sets, not sometimes perfect, but at least fair and accessible to broader communities. Point 9, in this case, societal perspective. Remote sensing was driven quite often by science curiosity, but we also need to listen to the society, what they need to be a part of the co-creation, co-design of observation. And this is also we need to work, and I would like to work on that. Last but not least, uncertainties. Any data sets are coming with a lot of uncertainties. Quantifying that, it's also the science. It equipped us knowing what we should expect for the data. And this is what I would like as a professor to work with my vision and mission. And with this, I would like to thank you for your time being here today with me. Thank you.
Thank you very much, Sasha, for an interesting talk that also inspired me as a layman, as a non-scientist. I'd like to ask you, you use the word normativity in this slide, you use the words fairness and sustainability. Are you on some sort of ethical mission here?
Maybe to open it informally, it's also a reflection and a self-criticism, how we do the science, and more doing the science for the years more critical to become, to analyze also what in terms of the fairness, who has access to the data, how technologies are transferred, how well we address the needs of the society. That brings me in terms of the fairness and my ethical approach. But thank you very much for your question.
Yes. Yeah. Thanks, Sasha, for a very nice talk and opening the eyes for the remote sensing possibilities of observing the land. In your new colleagues or in your team, a lot of us are working with what is just above the atmosphere, and you're talking multi-dimension and cross-scale and so on. Some of the remote sensing techniques, I guess, can also be used to observe what is happening in the atmosphere, so the emissions from the biosphere and from the human activities. Have you worked with this, or have you in your work come across atmospheric observations, or is there any plans that you can use remote sensing for the atmosphere?
Thank you for this valid question. And what I also show with the statement of Alto Leopold, that we observe the energy flows, both in the terrestrial, but also interaction with the atmosphere. So many processes directly or indirectly impact what is happening in the atmosphere. And this is what we can exactly measure, let's say, immediately with the change, but also link it to the processes such as the carbon emissions. If it's a deforestation occurs, we can re-quantify with the emissions related to the carbon release. Or like a land abandonment with the progressive vegetation, we can also quantify as the sequestration of the carbon. This is where I think I would probably say the best would be addressed in this way, directly or indirectly, but also we can look at the other new sensors, what I also mentioned, thinking creatively, how we can bring the satellite imagery to measure the methane emissions and link into urbanization processes or other transformations in the land systems and greenhouse gas emissions. Yeah.
I just want to ask, so you mentioned a lot of your previous work, but what some of the plans are you planning to look at Denmark in general moving forward, and what is if there's available data for it?
That's very important question. So about how much work is happening in terms of the Denmark and how it's relevant. And I believe this is a really core component where I'm also coming that, first of all, we see these days, it was just election past, how much all land transformations, how it became a core component of the political domain. And this is also shows how much the knowledge is needed here. Even sometimes we think all data is here, but in fact, when we look at the details, we miss a lot. So that gives a lot of, for me, room to do just in Denmark. And thanks for some funding, which are right now received, the work will be also expanded in Denmark. More details, let's say, in the grassland ecosystems, and hopefully we will look more into also details, small woody vegetation, other aspects, but also societally relevant. Yeah.
Yeah, thank you for a very interesting talk. I was wondering, you say we're living in exciting times. I mean, it's a little bit too exciting for me, but anyway, there's a lot of rumors going on some satellites being stopped now, or at least not analyzed because they are put up by Americans, and apparently, they're getting caught in their funds for analyzing it. Is this also pointing into that Europe is lagging behind in this? Do you see like that actually Europe is stepping up and taking more responsibility, or how do you see that in more long term?
Absolutely valid question. Saying about exciting times, we have a lot of worries, but also sometimes even these hurdles we probably need to look what we already have here and try exactly to preserve the not only science, but also protecting these achievements in terms of the remote sensing science and other aspects. And working on elaboration, I showed the figure how much science progress, how many publications we are just by opening the archives. And this is discussion comes exactly about the Lancet, if would be or not Lancet next mission, so continuation of long-term half-century record. This lesson about freeing data sets was also a lesson not only for the United States, how it progressed the science, but for entire global community. The greatest response was the European Space Agency, which placed Sentinel-1, Sentinel-2 publicly available data for everyone. In this way, I believe European Union, and many also countries went in the same direction. They learned this very important message that remote sensing, and this is also a state about my vision and mission, is that remote sensing is a public good. This is how European Union responded. We will definitely move, and there will be some challenges. And there will be also science how to cope with these gaps in the data. But I believe this is what also the communities and agencies understood, that it's very valuable good. Many stakeholders, they benefit from this data one way or another, both economy, commercial data, but also science by itself. And I look still a little bit optimistically. If there would be the hurdles, well, then we will take it and we will try to build the science house, still do the research with the limited observations. But there is no probably way going back, rather going way forward. And it's also our task to communicate to the politicians and decision makers that we need this data. And it's a public domain.
Yeah.
Thank you very much, Sasha. I really enjoyed it. And I was very inspired what you said about remote sensing being able to take the pulse of the Earth. And because many times we work on very specific founded issues, and we don't see the bigger picture. And so I can imagine that your work is an ability to actually bring different dimensions together, like leakage effects, what we do in Europe. And we think it's a good thing. It has actually double negative effects elsewhere. So making those interlinkages. So I was wondering, from this societal perspective and taking the pulse of the Earth, how do you see the the collaborations and the opportunities there.
Thank you. This is really wonderful. Rephrasing, I mean, just summarizing what remote sensing brings besides just the images and technologies, but how much it brings the collaboration. And believe this is the great answer. Also seeing myself having a background, master science in atmospheric science, then moving to the PhD in the forestry with the remote sensing, and then doing the postdoc with agricultural economists, and also later working as associate professor in geography, now coming slowly back into the roots. That means it brings a lot of interdisciplinarities. And I also hear a lot that there is a lot of curiosity about this technology, remote sensing, or GIS. And that also probably my task and the task who are equipped with this knowledge to translate and to bring these people together, to explain how that can be used and work co-creatively to see how we can measure certain aspects. This is also interest in science by itself. Yeah, what I showed, the remote sensing of the social, which was largely ignored, that the electromagnetic signal was always linked some response in the vegetation and other aspects, but exactly it tells us the pulse of the planet, also how we are feeling, where things are happening. So I believe this opens still opportunity, and there is a lot of room to do. There are still few programs like a global land program, or it used to be NASA land use land cover change program, where researchers were invited to work together and to expand this domain.
Hey, Sasha. Is there more questions? Plenty of time.
I'm not sure if I should look also the slides, maybe from the audience. Thank you very much for your questions. And I will try to see if someone would like to.
Oh, yeah, from the online. Yeah.
No.
No.
No,
Okay.
not yet.
Okay. So I think, could you help me in acknowledging this as a fantastic, start of your new job here? And then the department is host for a small reception just outside here afterwards. So let's thank you, Sasha, for enlightening us.
Thank you. And thank you very much for online audience as well. Thank you for your time.
Interesting with all these days.